Hello again, everybody. Today we are in section 3.3 and we're going to be talking about measures of central tendency and dispersion from grouped data. That is, data that's in a frequency distribution. So in this section, I'll show you how to approximate the mean of a variable from grouped data, and I'll also show you how to calculate a weighted mean. And I'll show you how to do this both by formula and by calculator. So here we go. Now, if your data is grouped into a frequency distribution and you no longer have access to the original raw data, it's not possible to calculate the exact mean, but sometimes it's necessary to estimate a mean from data that's already been grouped into a frequency table. And we can make a reasonable estimate of this. And to do that, we'll use the midpoint of each class. So let me show you what I mean by midpoint. The midpoint simply refers to the mean of two consecutive lower class limits. So for example, on this first class, the lower class limit is 0 and the next lower class limit is 500. So we would average 0 and 500 and we would get 250. And so the midpoint of this first class is 250. And you can see that 250 is right in the center of that class. And now let's do the midpoint of the second class. So we would take 500 and 1,000. The mean of 500 and 1,000 is 750. And now let's take 1,000 and 1,500. The mean of 1,000 and 1,500 is 1,250. And so you can see that 1,250 is right in the center of this third class, and 750 is right in the center of this second class. Now this first class contains 5 values. We have no idea what they were, but if we have to guess at those 5 values, the best guess we can make is just to put down 250 for each one of them. So to estimate the mean of a frequency table, one thing we could do is make a reasonable guess at the original data by using the midpoint as an estimate of each value in each class. So now we're going to find the mean of the data represented in this frequency table. My first class contains 2 values, the second class contains 3 values, and the third class contains only 1 value. And we have no way of knowing what those values were. However, we could make a guess at each of these values by looking at the midpoint of each class. Now this class goes from 4 to nearly 8, so halfway in between 4 and 8 we find the value 6. So 6 will be the midpoint of the first class. And then the second class goes from 8 to nearly 12, so halfway between 8 and 12 we find 10. And then this third class goes from 12 to nearly 16. So even though we don't have a fourth class here, so we can't see the next lower class limit, you know from common sense that the next lower class limit would have to be 16. And so the midpoint of this third class is going to be 14. Now if we've done everything correctly, the difference between each pair of consecutive midpoints should be the same. So the difference between 10 and 6 is 4, and the difference between 14 and 10 is 4. So you can see that just like we can add the class width to get from lower class limit to lower class limit, we can also add the class width to get from midpoint to midpoint. And now let's go ahead and make our list of numbers that will approximate our original data. So I see that in the first class I have 2 values. I'll put the 6 down twice. I see that in my second class I have 3 values, so I'll put the 10 down twice. And in my third class I have 1 value, so I'll put the 14 down just once. And now we know that to find the mean of these 6 numbers, we would add all 6 numbers and divide by 6. So if you add these 6 numbers together, you'll get 56, and then we divide by 6 and we find the mean is 9.3. Now again, this is an approximation or an estimate. We do not know for sure that these numbers are exactly the raw data. In fact, I would guess they're probably not exactly the raw data, but most likely some numbers are below the midpoint and some numbers are above the midpoint, and hopefully it all comes out in the wash. Now the method we just used is fine as long as your frequency distribution is small, But if the sum of the frequencies is large and you have to make a big list of numbers, then this method becomes burdensome. So we have a formula to help us. Here is the formula for the mean of a frequency distribution. It says mu equals the sum of x sub I times f sub I divided by the sum of f sub I, where x sub I represents the midpoint of each class and f sub I represents the frequency of each class. So now I want us to calculate the mean of that frequency table again, but this time using the formula. So here is our frequency distribution, and I've already got the midpoints copied in here. So let's make ourselves another little column over here, and I'll call it x sub I times f sub I. So remember, the formula says to sum each of the x sub I times f sub i's. So I need to take the midpoint and the frequency and multiply them together for each class. So 6 times 2 is 12, 10 times 3 is 30, and 14 times 1 is 14. And then the formula says to add those products together. So if we add 12 and 30 and 14, we will see the sum is 56. So now, according to the formula, we take the sum of those products and we divide by the sum of the frequencies. So if you add the frequencies together, 2 plus 3 is 5 and 5 plus 1 is 6. And again, we'll see that 56 divided by 6 is 9.3. Now, you can probably agree with me that this is almost exactly what we did on the previous slide. We just did it a little differently. So this way, we're taking a shortcut. We don't have to write a list of all the numbers. We just know we're going to count this midpoint this many times, and we do that for each class, and then we divide by the total number of observations. However, even though that formula does simplify things for us a little bit, if we have a frequency distribution with lots of classes, we can still find that it's a little tedious to use. So I'd like to show you how to use the one variable stats command on your graphing calculator. Now, to find the mean of a frequency table, we'll have to use both list 1 and list 2 at the same time. So what I want you to do is put the midpoint of each class in list 1. So I'm going to come over here, and you remember that the midpoint of the first class was 6, and the midpoint of the second class was 10, and the midpoint of the third class was 14. And then I want you to go to list 2 and enter the frequency for each of those classes. So the first class frequency was 2, and the second class frequency was 3, and the third class frequency was 1. And now I want you to press Stat and go over to Calc. We're still using the one variable stats command, but this time we'll need to tell it that our numbers are in list 1, but our frequencies are in list 2. So arrow down here and go second 2 and then calculate. And people who have the old operating system, hang tight just a second and I'll show you how to do it in just a second. And so now let's press enter, and we see that the mean of this frequency table is 9.3, just as we calculated. And now I'm going to go back and clear everything out and show you how to do this on the old operating system. Okay, now I'm using the old operating system, but I still have the midpoints in list 1 and the frequencies in list 2. So now when I press Stat, Calc, one variable stats, I don't get that little screen that asks me for the frequency list. So I need to tell the calculator that I want it to average the numbers from list 1, but I need it to use the frequencies in list 2. So after you put one variable stats list 1, then you're going to hit comma right here, and then list 2. So second 2, and then enter. And there is your one variable stats screen for that frequency distribution. Now here is example 1, where we're going to use the calculator to approximate the mean of this frequency distribution. So it says the frequency distribution in the table represents the 5-year rate of return of a random sample of 40 large blended mutual funds. Use the calculator to approximate the mean 5-year rate of return. So you can tell that this frequency distribution is large enough that we really probably don't want to have to use the formula, because the more classes you have, the more tedious the formula is to use. So I'm going to bring in the calculator here, and I already have set up the calculator with all of our class midpoints in list 1 and all of our frequencies in list 2. So now all we need to do is press Stat, Calc, one variable stats, and this is the old operating system. So now I need to tell it that I want to use each of the numbers from list 1, but I need to count it the number of times that it occurs from list 2. So I'm going to say second list 1, comma, second list 2, and then enter. And you know that if you're using the new operating system, you would put your data from list 1, but your frequency list would be list 2. So now I'm going to enter, and here is the mean of our frequency distribution. So we estimate that this mean is about 13.1. Now let's talk about weighted means. A weighted mean is used when some data values need to count more than others in an average. This is how GPAs are calculated, since some classes count more than others. And many instructors use a weighted average to compute a course grade. Now, the formula for the weighted mean works exactly like the formula for the mean of a frequency table, and so we can calculate weighted mean using the same one variable stats command on the calculator. So first we'll do it by formula. This example says Isabel has just completed her first semester of college. She earned an A in her 3-hour psychology course, a B in her 4-hour biology course, a C in her 3-hour history course, a B in her 3-hour economics course, and an A in her 1-hour drama course. Calculate Isabel's GPA for this semester. Well, let's make ourselves kind of a little table. So here I've got a place for each course, the number of points she got for that course, in other words, her grade, and the number of hours each course is worth, because you know from experience that a course that has more hours counts more heavily in your GPA. So here are all the courses that she's taking. Now an A is worth 4 points, a B is 3 points, a C is 2 points, a D is 1 point, and an F is no points. So let's see here. In her psychology class, she got an A, so that'll be 4 points. In biology, she got a B, so that'll be 3 points. In history, she got a C, so that's 2 points. And in economics, she got a B, so that's 3 points. And in drama, she got an A, so that's 4 points. Now, the psychology class was 3 hours, biology was 4 hours, history was 3, econ was 3, and drama was 1. And now let's get a look at our formula here. This was the formula that we had for the frequency table. Now, really, these are not frequencies, these are weights. So if you look at the formula for the weighted mean, instead of F sub I, they'll have W sub I, but I didn't bother to change it. And it works the same whether you write W or F. So let's go ahead and make ourselves a column for X sub I times each weight. And for psychology, 4 times 3 is 12. For biology, 3 times 4 is also 12. For history, 2 times 3 is 6. For econ, 3 times 3 is 9. And for drama, 4 times 1 is 4. And now if you look at the formula, it says to add all the products together. So we should add these numbers. 12 plus 12 plus 6 plus 9 plus 4 gives us a total of 43. And we divide that by the total frequencies, or the total of the weights. And so here we're going to have 3 plus 4 is 7, 7 plus 6 is 13, plus 1 is 14. So she was in 14 hours, and 43 divided by 14 is 3.07. So Isabel's GPA is 3.07. Let's do this next example on the calculator. This says, in Blake's trig course, attendance counts for 5% of the grade, quizzes count for 10%, exams for 60%, and the final exam counts for 25% of the grade. Blake has 100 average for attendance, 93% for quizzes, 86% for exams, and 85% on the final. Determine Blake's grade for the course. Okay, so what we could do is put a list of all of Blake's grades for each category in list 1, and then put each category's weight in list 2. Let's try to do it the same order they have it in the problem. So it says he has 100 for attendance. I'm going to go ahead and put 100 in list 1. And it says he has 93 for quizzes, and then 86% for exams, and 85% on the final. Okay, now in list 2, I'll put the weight that each category receives. Attendance is 5%. Now you can either put 0.05 or you could just put 5, as long as you're consistent about it. If whatever you choose, you need to do it all the way down. So I'm just going to go ahead and put 5 here. And for quizzes, that's 10%. And then exams are 60%. And the final is 25%. And now let's average. So we'll say stat, calc, one variable stats, data in list 1. For this operating system, we have comma, and then frequency list is list 2, and then enter. And Blake's average right now is 87.15. Now this next example we're going to do by formula, just in case you ever need to find a weighted mean when you don't have a graphing calculator handy, or in case you are asked to show your work on a quiz or a test. So we'll do one more together using the formula. This one says Michael and Kevin bought a mix of chocolate-covered almonds, chocolate-covered peanuts, and chocolate-covered raisins. They bought 4 pounds of chocolate-covered almonds at $3.50 a pound, 3 pounds of chocolate-covered peanuts at $2.75 a pound, and 2 pounds of chocolate-covered raisins at $2.25 a pound. Determine the cost per pound of the mix. Okay, so what we want to do is first make a little list. I've written down here chocolate-covered almonds, peanuts, and raisins. And then let's go ahead and write down the price of each item and the weight. For the almonds, they bought 4 pounds at $3.50 a piece. For the peanuts, they bought 3 pounds at $2.75 a piece. And for the raisins, they bought 2 pounds at $2.25 a piece. And let's get a look at our formula here. The formula says calculate each value times its weight, and then add those products together, and then divide by the sum of the weights. So let's make a little column here, and we'll say 3.5 times 4 is 14, 2.75 times 3 is 8.25, and 2.25 times 2 is 4.5. Now according to the formula, we add all of those products together. 14 plus 8.25 plus 4.5 gives us a total of 26.75, and then we put that over the sum of the weights. So if you add these weights together, 4 plus 3 is 7, and 7 plus 2 is 9. And so the average price per pound of the mix is 26.75 divided by 9, which is 2.97 per pound. And now I hope that you will take your graphing calculator and enter these numbers in list 1 and list 2 in your graphing calculator, and just make sure that you can get the mean that way as well.